Hello everyone, today we're going to talk about LangChain4j, a new Java framework to help you develop Java applications using large language models. I'm Julien Dubois, I'm leading Java developer relations at Microsoft, and I will be your host for this introduction to LangChain4j. So, what are we talking about? LangChain4j is a port of LangChain, which is a very popular framework used in Python and JavaScript. Its goal is to help you develop applications using large language models, and it's fully open source, so you can find it on GitHub and use it for free. Why would you want to use LangChain4j? There are three main reasons. The first one is that it gives you an abstraction layer on top of all the different LLMs. So it makes it easier for you to use them, but also to switch them depending on your needs. Second reason is that it helps you integrate all of those LLMs together and chain them, hence the name LangChain4j. And last but not least, it gives you a lot of utilities and tools that you will want to use when you develop your applications using LLMs. We're going to see that very quickly because I've got 7 demos showing you all of this. And the first one will be creating an image like the one on this slide. This was created by LangChain4j using 2 lines of code. And we're going to see right now how I did that. So let's switch to the IDE. And we can see here I created a very simple Spring Boot application. You can see my main class, annotated as Spring Boot, and I can run it. So let's run it right now. And once this application is running, I can go there and we can see here my main page and my demos, which are here. I'm clicking on the first demo and let's have a look at what this does. So on the left-hand side here, you can see I've got a model configuration for an image. So this is an Azure OpenAI image model, and I configure it using very few parameters, typically the endpoint and the API key. And I'm using here DALL-E3 to generate my image. Very simple configuration, and that gives me back a Spring Bean, which is an image model. That image model is not an Azure OpenAI class. It's a generic class from LangChain4j. It's an interface that many other language models can implement. So again, here I'm not using anything specific to Azure OpenAI. I'm neutral, so easier for me to use it and also to migrate and change different models depending on my specific needs. We'll see that in a future demo. First, let's generate our image. So we saw to configure it, very easy. Now let's see how we use it. I've got a controller here, and my first demo is here. So my question is, give me a coffee mug in Paris, France. And I'm asking my image model to generate, using that question, well, an image which has an URL and giving me the URL back. So let's have a look at my web browser. It gave me that URL. And if I click on it, I can go to see my image of a coffee mug in Paris, France. So it worked very easily. And as we saw, only basically 1 line of code to configure, 1 line of code to use, extremely easy to generate an image. Now, let's use something that might be more useful than generating that image. And let's go to the second demo. I'm clicking on it. It's called Simple Question. Let's have a look here what it does. We're asking it, who painted the Mona Lisa? And same thing as before. So it was configured here using another LLM. This time I'm using GPT-4, sorry. Same kind of configuration, give it an endpoint and a key. And that's all. And now to use it, I'm in 1 line, I'm telling it, okay, well, generate me an answer from this question. And then we're going to, show this on our web page. So let's have a look. And it's answering me that the Mona Lisa was painted by Leonardo da Vinci, blah, 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 blah. This is done by GPT-4, and it's pretty accurate and pretty good. Thank you, GPT-4, for this. Now, I don't know if you saw it, but it was a bit slow to generate, and this is connecting, of course, to Azure OpenAI. Maybe I want to use another language model. And let's have a look at my chat model configuration here. I had this bin. So it's a chat language model. It's an interface, but the implementation is done using Azure OpenAI. Let's move it and use the bin that is below here. Oops, sorry. This time I'm going to use MistralAI. Same configuration, still giving me a Spring Boot bin, using a URL, using a key. But this time, instead of using Azure OpenAI, I'm going to use MistralAI. You can note here, I'm not changing anything in my code. Again, I've got an abstraction layer, don't need to change my code. I learn this API once and I can reuse it, which is good for me, but that's also good for the maintenance of my program, or maybe for my test. Maybe I want to use Azure OpenAI in production, but MistralAI in test, because it's cheaper and it's faster. So let's have a look. And for this, I'm going to use a tool which is called LM Studio. So I'm going to use Azure MistralAI on my local machine. So LM Studio is a free tool that you can use to download large language models and use them on your machine. And you can run them as a local server. So this is loading Mistral Instruct 7B, which is a small language model made by MistralAI. Why would I want to use it here? Well, it's local, so I can use it more easily. It's fast, it's free. Well, lots of good reasons to use something locally instead of using Azure OpenAI. But then we're going to see maybe it's not as good as Azure OpenAI. So maybe in production, you would rather use GPT-4 on Azure OpenAI. It's a choice. So let's do that REST request again. Let's just reload that page. We can see here, we have the answer here from MistralAI. And I got my answer. So still a good answer. Leonardo da Vinci painted the Mona Lisa, but it's much shorter. So we can see here, MistralAI is faster, runs locally. It's cheaper, of course. I didn't pay anything. But then it's not as good. So maybe I want to switch between those two large language models for business reasons, because one is better than the other. Maybe I want to use them for technical reasons. This is good enough for testing. Well, let's use this for testing locally with and running my large language model in my CI platform. But in production, maybe I rather use Azure OpenAI because it's better. So lots of good reasons to use one or the other. And all those reasons make it very interesting to use LangChain4j because, as you can see, migrating from one implementation to the other is as easy as here, changing this annotation. You can do better in Spring. You know, you got typically you got profiles. I would use Spring profiles personally to make it easier, but you get the point. Very easy to migrate from one implementation to the other, and my code here didn't change at all. So really cool. Now let's go to my third demo. We're now going to have a look at the little tools and utilities that are provided by LangChain4j for a more advanced usage. You probably don't want to have that question put that way. Usually, people add something what we call a system message, and the system message gives more context to the AI, to the LLM. And here my system message is, I am the king of France, talk to me with extreme difference. And that gives some context to the LLM, and it's not going to answer me in the same way. I just restarted my app because I changed my Spring Bean. And now let's go to that advanced question. And so we're going again to have an answer this time by Azure OpenAI, so it's going to be a complete answer. But this answer gets the context, which is, I am the king of France. So it calls me Your Majesty, blah, 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 blah. So a better answer, and thanks to a first small, that's the first demo, of course, a small utility provided by LangChain4j. Now let's get a little bit further, and let's do something that doesn't work well. So this is basically the same question as we had before. We're just asking a question to the large language model, but this time we call it, where did you see that painting? So let me click on it because it takes some time to generate, and let's have a look at what we're doing here. We've kept talking about the Mona Lisa. So now we're asking it, well, where did you see the Mona Lisa? Where can you see it? And the answer is a little bit, well, it's not what we are waiting for. It says, I'm sorry, but you didn't specify which painting you were referring to. I don't understand what you mean. It didn't have the context. This is true for all REST APIs using LLMs. They don't have memory. In the end, there's just a REST API that you call, and it doesn't remember what you asked it before, which is bad, and which is probably what you don't want. And so basically, nobody is using LLMs that way. Well, only for very simple use cases, but for normal use cases, you don't want this. So that's a second nice utility. Well, let me just click on my demo before. That's a second nice utility from LangChain4j. It gives you a memory. So those are LangChain4j classes. There are different ways to configure those, but this is a very simple way to do it. And instead of asking my question, why did you see that painting, I'm giving it some context before. If we have a look here, I've got a chain. So first question is that, well, who painted the Mona Lisa? And my second question is, where can you see this painting? So those are the two questions I did before, and it didn't work before. But this time, I've got a memory, so it's going to remember that. And it's going to answer me correctly this time. Oh, the Mona Lisa. Well, I know which painting you're talking about. We talked about it earlier. And the Mona Lisa is displayed at the Louvre Museum in Paris, France. Wonderful. And that's the right answer. So we've already covered two interesting points using LangChain4j. The first one is that we can migrate easily from one LLM to the other. And the second one is that here we've got lots of interesting tools that you want to use, that you will need to use anyway. So, well, you'd rather use them with a framework like LangChain4j, which provides you with everything out of the box. Now, let's go a little bit further. Let's go back to my presentation, and let's talk quickly about retrieval augmented generation, or RAG, which is what probably you've heard about, and which is a little bit complex, but we'll see. Thanks to LangChain4j, it's very easy to use and understand. So you've got two main limits with LLMs like GPT-4. First of all, they have a cutoff date. So that model was trained at a certain date. And if you ask it, who won the football match yesterday? It doesn't know because it was trained before. Second issue, they don't have your internal company data or your private data. It's basically trained on Wikipedia data, on generic data. And if you ask them, oh, what is the travel policy inside my company? It has no idea about it because it's a private document within your company. Those are basically the same limits in the end. The LLMs are trained on some generic data, which might be a bit old. And your issue is that you want to give them more context. You want to give them more recent context, or you want to give them a private context. And for that, you need to use probably a vector database. So how do you give them more context? First of all, you ingest this new or private data using what we call embeddings. Then you store that data in a vector database, and then you request the vector database, the data you need, and you send that as a bigger context to the LLM. And this is where LangChain4j is really good at. It already supports more than 10 vector databases, including Azure AI Search, which is the one I'm going to use. But if you want to use Elasticsearch, if you want to use Milviews, if you want to use PostgreSQL, they are all supported. Some of them might be more efficient because they are pure vector databases. Some of them are more generic, like PostgreSQL. They've got support for vector databases. And the good thing, probably with PostgreSQL, is that you already know how, in your company, how to maintain it and use it. So it's all choices. Same reason as before to use LangChain4j. It's easy to switch between all of those and take the best for your specific use case. I'm going to use, in this case, Azure AI Search, not only because it's a good vector database, but if you look at my last point, because it's got advanced features like keyword search and semantic re-ranking, which are coming. If you have a look at this link, so it's a pull request that I created that is going to be merged very soon. And you will see that semantic re-ranking gives you even better results than just using a pure vector database. So that's pretty interesting. And thanks to LangChain4j, it's all including all free for you to use. So you can have the best solution depending on your need. And again, very easy to switch between solutions. So you can take the one which is the best for you for that specific moment or for your specific business, and then switch later. So let's have a look at using vector databases. And that's going to be my next demos. Well, first of all, let's do demo 6, data ingestion. This one is very fast. You can see here in the logs, I'm ingesting some data. What's happening here? How does this work? And we're going to talk about embeddings. So here, I've got some private data. I took something very easy. I've got 6 items. And you can see that 3 of them are fruits. I've got banana, apple, and strawberry. Pizza is not a fruit. It's a trick. I'm taking those 3 items, and the first thing I need to do is transform them into vectors. So there's different ways to do this, and for this you need what we call here an embedding model. if we look here in my Spring Boot configuration, I've got an embedding model configuration. In fact, I've got 2 of them. Again, this is something now you're used to with LangChain4j. You can switch different models depending on your needs. The one I'm using here is the one from Azure OpenAI, and I'm using text embedding ADA 002, which is a good one. So I'm going to have some good embeddings created out of this text. If I want to have something faster but not as good, here I've got another embedding model, which can run locally inside my Java code. So faster, cheaper, well, it's running locally, but not as good. If you do some tests, you will see it's not as good, but might be enough for testing. Always the same opportunity with LangChain4j to switch very easily implementations, and then I'm having the same interface, so my code doesn't change. That's wonderful. So the first thing here, this is taking typically my banana and transforming it into a vector. We'll see in our demo what this vector looks like. Once I've got this vector, I want to store it into what we call an embedding store. So that's a vector database. In our case, here we can see my vector database is Azure AI Search. Again, this is supported by LangChain4j, so very easy to configure it in one line. And you can see my vectors, I've got 1,536 dimensions. If you want to look smart, you just say that you know that number. It's a magic number for most embeddings. So we are transforming typically our banana into a vector of 1,536 dimensions. So it's not in 3 dimensions like we are now. It's lots of dimensions, and then it's just some mathematical calculations to see which vector is closest to the other. So what we just did, we took those 3 items, transformed them into vectors, and ingested those vectors into a vector database. Okay, now let's use that using my demo number 7. We're going to query that vector database. We're having the answers very fast, so let's have a look at what we were doing. So our question was, give me the fruits, give me fruits. And again, our 6 items were transformed into vectors. And what my vector store is going to do is going to take the fruit, transform it again in an embedding, so using the same vector model in that space, and then it's going to calculate which vectors are closest to the fruit. And of course, what is close to a fruit? Well, we've got banana, we've got apple, we've got strawberry. And if we look at the answers, banana, apple, strawberry. Yeah, that's good. It worked. If you want to test, we can say, for example, instead of looking for a fruit, you can say, I want to look for a keyboard. This one is pretty fun because remember our items? Well, keyboard and computer are probably pretty close. Do you have anything that is close to a computer? Well, Apple does computers. It's also a brand. So if we look at this and do our question again, what are our answers? Computer, Apple is less relevant indeed. And then banana, probably totally stupid. Maybe they're using makey. You know, makey, you can do bananas that act as keyboard. Maybe that's because of this. I don't know. And here again, the better your embedding model is, the better this result will be. Same thing, if you use Azure OpenAI, you will have a better result than if you use a local embeddings, but it's also costing more money. Maybe for testing, that's good enough to use a local embedding. I know you wanted to see those vectors, so I'm going to do a last demos. So it's the same as what we just did, but this time it's giving us the vector. So you can see that the banana here was transformed into this vector of 1,536 floats. It's an array of floats in Java. And what my database did is it tried to find the vectors that was closest to the fruit. And well, if you do the maths, you will see that the vectors which are the closest to fruit are banana, strawberry, and apple. Okay, once you've done this, you're nearly ready to do RAG because you've got your LLM, you've got your vector database, you just need to merge them. And if you want to have something a little bit more advanced, you can have a look at what we have here with semantic re-ranking. This is coming for Bing Search, so this is coming from Microsoft Research, and it gives you an even better ranking of the data that is coming out of this mechanism. So thank you for following this quick introduction to LangChain4j. Again, LangChain4j is a layer of abstraction that you can use to switch between different LLMs. And we've seen how easy it is and the different types of LLMs that you could use. It gives you easy integration of those APIs. You've seen how easy it is to use them all together because you've got a common API. And last but not least, it's got some very nice tooling that help you get your work done faster. So thanks to LangChain4j, you can get up to speed on LLMs very easily and very fast, and also have your business requirement complete thanks to all those different LLMs that you can switch depending on your specific needs. Thank you, and see you for our next video on LangChain4j. Bye.